Hello friends, welcome to Nabla Mami Online Maths. Today, we are going to learn how to evaluate limits within seconds. And I have some examples on the board to illustrate this. So let's go through the examples on the board. So you see that example 1 is June 2014, question 40, what's it? Which is the limit value of x approaches 3. 2x squared plus x minus 21 all over x minus 3. This means that whenever you see x, you are putting 3. So first, if you are to work this, you put the limit in the denominator side. If the result is 0, it means that you have to work further before you can now what? Do the substitution. But if it is not 0, you can continue. So if I put 3 here, 3 minus 3 is 0. And you know that any number over 0 is undefined. It means that I cannot put 3 straight forward. So I want to give you a trick that you can use to work questions like this within 10 seconds. And when you choose your right answer. Because if I put here 3 minus 3, you see that the down will be 0. If I put 3 at the top, 3 squared is 9. 9 times 2, 18. 18 plus 3, because x is 3, to be 21. And 21 minus 21 is 0. So you see that you have 0 over 0. And 0 over 0 is undefined or infinity. But if you are not careful and you do it that way, you think that the answer is A, which is 0. So no, mostly limits questions, if you are not careful and you are choosing 0, 0, no, you won't get it. So you have to check the denominator first. If it is 0, then you have to simplify it before you can now substitute the limit. And most of the books that we use, the textbooks, the method that they use is the factorization method. They will factorize the top and factorize the down. And you can, at the end, you see that some of them will cancel each other before you now do the substitution. And that method is too long. It's used in the theory side. So I'm going to give you a trick that you can use for the objectives. Within 10 seconds, then you get your answer. And that particular method is going to be differentiation. What it means that you differentiate the numerator and divide by the differentiation of the what? The denominator. Before you can now do the substitution. Meaning to work this, you have to have the basic knowledge of what? Differentiation. And mostly, we are going to use the power rule. And you have to also know two concepts here. Anytime you have to differentiate x, your result will be 1. And anytime you have to differentiate a constant, then the result will be what? 0. If you have to go back and revise the basic conditions or concept of this differentiation. So let's start with example 1. So if I have 2x squared plus x minus 21, I have to differentiate the numerator. To differentiate the numerator, 2 multiplied by 2 will be what? 4. But if I subtract 1 from the power, it will now be what? X. Differentiating x will be what? 1. Differentiating minus 21 is 0. So I will now divide by the differentiation of x, which is 1. If I have to differentiate minus 3, it will be 0. So what I'll have there will now be 4x plus 1. But you know that that is 4x plus 1 over 1 will give me this, because any number over 1 is that number. So I can now substitute the value of x there. That is, whatever I see x, I'm putting 3. So 4 times 3 is 12. 12 plus 1 is 13. So my answer will be 13, which is what? D. So let's go to November 2010, question 10. That is what's it. You see, this particular question, I have the limit value of x approaching 1. And the numerator is 2x squared minus x minus 1. All over 3x squared plus x minus 4. So to do this within seconds, what I'll do is I'll differentiate the top. So 2x squared will give me 4x if I differentiate it. Minus x, if I differentiate minus x, I'll get 1. Differentiating minus 1 is 0. So all over the differential of this, 3x squared will give me 6x. Plus the differential of x is 1. Differential of minus 4 is 0. So if I now have it this way, I can now substitute 1. I'm doing this thing because if I put 1 here, that is 3. 1 squared is 1 times 3, that will be 3 plus 1, which is 4. And 4 minus 4 is 0, so it cannot work. That's why I have to differentiate before I can now do the substitution. So here, it means that whatever I see x, I'm now putting my 1. So 4 times 1 is 4. 4 minus 1 is 3. I'm doing the substitution. So here, if I put 1 here, 1 times 6 is 6. 6 plus 1, 7. So that means that the right answer is 3 over 7. Then which is A. You go and shape that one. Then the last part, I have 3x squared minus 5x plus 2. Or all over x squared minus 1. But the limit is x approaching 1. And this one was November 2016. Question 28. So what you need to do is that just use the basic trick, which is the differentiation of the numerator over the differential of the denominator. So if I'm to differentiate 3x squared, it will give me 6x. Differential of minus 5x is minus 5. Differential of 2 is 0. So I'll say over. The differential of x squared is 2x. Differential of minus 1 is 0. So if I differentiate everything, I'll get 6x minus 5 all over 2x. So you know, whatever I see x, I'm now putting 1. So here it will be 1 times 6, which is 6. 6 minus 5 is 1, over. Putting 1 here, it will be 1 times 2, which is 2. That means that my answer is 1 over 2. So you go to wherever you see the 1 over 2, you select that one, which is C. So this is how we evaluate limits expressions in the objectives side. Within 5 or 10 seconds, you get your answer and go and what? Sheet. So anytime you see a limit question in the objectives, just do this quickly and go and what? Sheet. But if it is theory, you use the what? The factorization method. So I'll get time and record another video that will teach us how to solve the theory questions under limits when it is section B and you have to show working and they will mark it. So just take this particular concept so that next time you see a limit question, you just use that one to evaluate it. Thank you for watching this video. If this is your first time of watching, kindly subscribe to my YouTube channel, Nabla Online Maths, so that you'll be notified anytime a new video is being uploaded. You can also share my Facebook page for others to watch. Thank you once again and have a nice day. Bye-bye.